Good day, everybody. How are you all doing? Hope you're doing great. This is Dr. Nandi. Those of you who do not know me, I have a YouTube channel where I upload all kinds of travel videos from all around the world, as well as I upload stat videos. My travel videos are short. My math videos, of course, a little bit longer. So you can watch my math videos because they're helpful in solving math problems. They're like a assist tool for you. Also, if you get bored, you can watch my YouTube videos on travels all around the world. So without further ado, today let's get started. Today we are going to work with sampling distribution of proportions. So here I go. So as I said, we are going to talk about sampling distribution of sample proportion. And that is, we are going to work with the central limit theorem for sample proportion, for sample proportions. And this theorem states that the mean of the probability distribution of sample proportions, also called also called also called sampling distribution, and it is denoted by symbol mu p hat. So this theorem states one, mu p hat, which is the mean of the probability distribution of the sample proportions, is equal to p, which is the population proportion of success. So you may ask, what is success? So suppose you're tossing a coin and you're looking for head face up, then head is your success. So this is the first tenet, or the first thing that is stated by the central limit theorem. It basically locates the position of the mean of the sample proportion. And the other tenet is second one, that sigma p hat is the standard deviation of the sampling distribution. Standard deviation of the sampling distribution. Sampling distribution is equal to square root of p times 1 minus p. Again, p is the population proportion of success divided by n. What is n? N is your sample size. Why do we work with sample size? Why do we work with sampling distribution proportion? Because it's very difficult to reach the entire population. Suppose in a college of 10,000 students, some population size is 10,000. I want to find out what proportion of P of students have laptop computers. So I want to find the mean, or I want to find the population proportion of success or population proportion of students who have laptop computers. It can be as high as say zero point 0.8, but I do not know for sure. Do I have the time to contact the entire population? No. Then what do I do? I work with much smaller samples. Okay. Remember, n is your sample size. And as this theorem states, the center of the sampling distribution. Now, what is the sampling distribution? How does it look like? So I will draw it for you here in a minute. So let me draw it over here. This is your p hat or sample proportion. Okay. And the sampling distribution will look like this, tall and thin. This is the probability distribution of sampling distribution or probability distribution of p hat. Distribution of p hat, also called sampling distribution. So your probability on the vertical axis. Maybe I can draw better one this way. Let me try another ink maybe. Instead of this, let me try this ink. So it will probably look tall and thin. Oops, not good, not good. So, okay. So the peak where the relative frequency is highest. This value, according to the central limit theorem, this is the mean of the sampling distribution. This is equal to P, and sigma P hat is equal to square root of P times 1 minus P divided by N. Does it really hold good, these two tenets or these two uh, aspects of the central limit theorem of population of sample proportion? Let's check it out. Let's check it out. Let's think of a situation. So we are going to say, check it out by toss a fair coin 2 times and look for proportion of heads in the sample. Proportion of heads for proportion of heads in the sample. Heads, which we will call p hat in the sample. So how is that gonna work? So what are the four possibilities? Why four? Because we're starting with 2 coins, with 2 coins. Okay. Mm. The four possibilities are, it is okay. So we can get head, head. That means both the coins land with head face up. Then the first coin with head and the second coin with tail face up. Or we can have a situation where both coins land with tail face up, or the first one tail up and the second one head up. So now we are looking for P hat, okay, which is the sample proportion of head. Sample proportion of heads. Okay. So here the first case, both are heads. So it is 2 out of 2 equal to 1. Next one, it is 1 out of 2 possibilities is 0.5. Next one, both are tails, no head at all. 0 out of 2 is 0. And next one, 1 out of 2 is 0.5. So we have four possible values of p hat. Enter the four values of p hat values of p hat in L1 of TI-84. So you first clear the memories of the calculator by pressing second button, second button, then plus button, then number 4, which gives clear all list on your calculator screen. Then you hit enter and you say done. That means memories are cleared. Memories are cleared. Are cleared. Next you hit stat button again. Stat button, and then select or press number 1, which is edit, and enter 4 values of p hat which we listed above in L1. Okay, so let's do that. So again, first is second button on the top left, then plus button on the bottom right, then number 4, clear all list on the calculator screen, hit enter, done on the calculator screen. Okay, then stat button in the second row, then number 1 is edit, then enter the 4 numbers in L1, which is 1.50 and then 0.5. 0 is a possibility too. Okay, these are the proportion of heads in each of the samples. Okay, so we will calculate the mean of all these sample proportions. So calculate mu p hat, which is mean of sample proportions, mean of all sample proportions, and sigma p hat, which is standard deviation of all sample proportions, of all sample proportions. Okay, so we will do that. So how do I do that? I will show you in a minute. What buttons we press? We press the stat button, then highlight calc on the top row by moving the cursor on top of calc, the black rectangle, then select number 1, which is one where stats. Okay, so stat button, highlight calc on the top row, then select number 1. My list is L1. My frequency list should be empty. I have nothing in L2. So frequency list is empty. And then I calculate. Bring the cursor down on calculate and hit enter. And hit enter. Okay. Okay. Voila. What did you get? Let me show it to you. I got mu p hat, the mean of all the sample means. Okay, let me change the color of the ink. Okay, so I got mu p hat, mean of all sample means, mean of sampling distribution, which is equal to mu in the calculator screen, is equal to 0.5, and this is the mean of the uh, this is equal to actually population proportion of success. What is p? P is the population proportion of success, which is in the long run you expect to get 50% head proportion of success, in this case head or heads is also 0.5. Okay. But what about sigma p hat? That is the standard deviation of the sample proportions. Standard deviation of sample proportions of all p hats is equal to, according to the calculator, this is sigma x is equal to 0.35355. 355. 3, actually 3535. Okay. That's not related to P. P is zero point 0.5. But let's check on that. Let's check on that. So let me move a little bit up. Let's calculate. Let's calculate what is square root of P times 1 minus P over N. Okay. Remember my P is population proportion of success is 0.5, and I toss the coin total. Um, there are two samples each time, and there are four possibilities. N is equal to 2. Okay. Toss the coin two times. Two times. Okay. N is 2. Okay. So let's calculate this figure. So if I move it a little bit, I may want to change this back to this. So this will be square root of 0.5, 1 minus 0.5 divided by n is 2. So I will do second button and then x square button to get the square root. Inside the square root I will type this. So second button and then x square button gives me the square root. Inside the square root zero point 0.5, then left parenthesis 1 minus zero point 0.5. If you wonder where is the zero point 0.5, is the proportion of success in the long run for getting heads is 50%, right? 50% head and 50% tail. Now 0.5 times 1 minus zero point 0.5 divided by, I'm typing in the calculator exactly the way it is written. A divided by n sample size is 2. Why 2? Because I tossed the coin two times. And voila, that is also equal to 0.3535. Okay. Same as the standard deviation of sample proportions. Standard deviation of sample proportions. So what is the bottom line? The bottom line is true. What the central limit theorem states is true. That, so central, thus, what central limit theorem for sample proportion states is true. Theorem for sample proportions for, sample proportions holds good. Sample proportions hold good. Hold good. Hold holds good. That is, comma, mu p hat mean is equal to p, and sigma p hat is equal to square root of p times 1 minus p over n. You ask, why go through all this? What is the big deal? The big deal is he will hit the population proportion without contacting the entire population. As long as your sample size is large enough, like a sample of size 100 will do the job. You find the mean of the sample means or sample proportions, and that is equal to the population proportion. You hit the population proportion. Where the peak of the sampling distribution is highest, that is the population proportion. Okay, so that is the advantage of central limit theorem. Without working with the entire population, by selecting a sample large enough, and if you do the sampling distribution of sample proportions, that is the probability distribution of p hat, you hit the where the peak is on the horizontal axis, the value on the horizontal axis where the relative frequency is highest, like I showed over here. Okay, so this value where the peak is the highest is the mean or the population proportion of success. Mu p hat is equal to p. That is the way we are getting the population proportion of success without contacting the entire population, just by doing the sampling distribution without contacting the entire population of size 10,000. That is the advantage of central limit theorem. It helps us to characterize the population characteristics, in this case p, population proportion of success, without contacting the entire population. That is the advantage. Okay. So I stop here today. I know you have enough questions. You have a lot of questions because you may have difficulty in understanding some things. No problem. No problems. Just send me a comment or send me a question through comments and I will answer all your questions. I guarantee it. Okay. So if you like this video, please give me thumbs up. That really motivates me. If you like this video, share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button, and at the same time, hit the bell button that will notify you every time I upload a new video. Again, thanks for watching. Take care. Have a nice day. See you.